We're going to be discussing whether or not the coronavirus is actually alive. And we're going to discuss the criteria that biologists have set up to ascertain whether or not something is alive. So if you find something out in the world, you have to sort of meet these thresholds in order to call it actually alive. So let's get into it. So, again, the big question here is the coronavirus alive, or are viruses alive in general? And why is it that you think a virus might be alive or not? So I put here an image of Darwin's tree of life to sort of discuss whether or not viruses actually belong within the tree of life. So what are the characteristics of life, and can we use those characteristics to exclude or potentially include the virus within life? I keep getting in the way. So what are the characteristics of life? Let's just go through the list and decide whether or not viruses fit within those categories. So is the coronavirus highly organized? Because that's sort of the first characteristic of life. If you find something out in nature, if it isn't highly organized, it is not considered alive. So, I mean, here is this. This is a viral capsid. I don't know if it's coronavirus specifically, but coronavirus has one very similar to this. Here is a segment of the coronavirus's DNA. Here's a picture of the coronavirus. And so I think it's pretty safe to say, I don't think anyone out there would dispute that viruses are indeed highly organized. So put a little check mark up here. The next question is, does the coronavirus adapt to its environment? So in order to be living, you have to be able to change. You have to be able to be adapted to your particular niche, whatever that happens to be, through the process of natural selection. You also have to be able to change to specific things happening in your environment in a more acute way or a more immediate way. So does the coronavirus adapt to its environment? And the answer to that question is a yes. Principally because the coronavirus, and you don't need to worry about the terms lytic or lysogenic right now. That's not what we're worried about. But the coronavirus does adapt to its environment because it has these different cycles that it can go through. A cycle where it's sort of bursting out of cells all the time and making copies of itself. And another cycle where it's just incorporated into a cell's DNA and it's sitting dormant, waiting for particular conditions to start emerging again. So I would say pretty solidly, yes, indeed, the coronavirus can adapt to its environment. So the next question here is, the next characteristic of life is, do viruses evolve? Does the coronavirus specifically evolve? Because in order to be alive, you have to have some evolutionary origin. You have to have come from some common ancestor somewhere along the line. So this shows the evolution of a virus. And you can see it's over here, it's infecting whales, it's infecting carnivores, it's infecting deer, it's infecting primates. This is not coronavirus, by the way. It's just a nice phylogenetic tree that I found. But coronavirus follows this same exact pattern. But you can see here, there's this thing called a node. And we're going to talk about phylogenetic trees later on. Don't necessarily worry about this right now. But what this shows is that, yes, there is a common ancestor for all of these viruses that can be traced back to here, to this sort of central point. And so that showcases sort of the most basic mechanics of the evolutionary process. Later on in the semester, we're going to get into the details. Actually, we're going to get into the details of all of these things. I just wanted to show you guys here that, yes, indeed, viruses do evolve. Do viruses respond to stimuli? This is different than adaptation. This is an actual response to stimuli. And you might be saying, you're thinking to yourself, well, there are things that I think are alive that don't respond to stimuli, like plants maybe don't respond to stimuli. And I would respond to that by telling you that actually, yeah, plants do respond to stimuli. They have things called like phototropism or chemotropism, where they're growing toward light or they're growing toward different chemicals. So plants respond to stimuli. Certainly you and I respond to stimuli. Like if your little sister walks into the room right now, you're either going to respond by telling her to be quiet or, getting up and walking out, whatever the case may be. But the question for us now is, do viruses respond to stimuli? And the answer is probably not, maybe not. We haven't shown conclusively that viruses do not ever respond to stimuli. So we don't think that they do. We think they just kind of emerge and they do whatever they need to do without actually responding to their environment very much. So probably not is the answer. The next question, or the next criteria that you need to be alive, is you have to use energy. Everything that's alive takes in some sort of energy from the environment and utilizes it to do something, whatever that thing happens to be. This morning I ate some biscuits. That's how I got my energy, and I'm using that energy now to do this lecture for you guys. All living things use energy that they have gotten from the environment. So the question is, do viruses actually use energy? Sort of. They use whatever organism they're infecting's energy. So they do use energy, but they don't actually really incorporate it. They just kind of hijack a cell's energy. So they're sort of like using energy like the same way that vampires use energy. They're just sort of draining from other things. So they aren't really using energy like the other things that we would consider living use energy. So we'll put a question mark there. Do viruses reproduce is the next question, because all living things reproduce. And when I say that, I don't mean that like if you haven't had kids yet, you aren't living. That's not what I mean. I mean that you have potentially, your species has the potential to reproduce. And so your parents obviously had you, you're a member of the same species as your parents, and so you and I would fit this criteria, whether or not we've had kids. So in order to be alive, your species has to have the ability to reproduce. Do viruses have that? And the answer is, yeah, sort of, but they don't do it on their own. Again, you don't need to worry about this diagram right now, but it's just showing that viruses are just using a cell's machinery. And so, yeah, they sort of reproduce, but not, they can't reproduce without the ability to infect something else. And so really, do they? Not really. Sort of, maybe. Yes, they do reproduce, but not on their own. So it gets another question mark. The next question, the next criteria is this question of growth and development. So in order to be considered alive, you have to be able to grow and develop. All living things aren't just sort of born the way that they're going to be. They have to undergo this process of growth and development, and viruses do not do that. They are fully formed the way that they're going to be pretty much after they emerge from their host cell. And so viruses don't grow. Viruses really don't have any kind of process of development. And so this is one I would say, no, probably not. Viruses do not grow. The next thing we need to be thinking about is, can viruses maintain homeostasis? And what do I mean by homeostasis? So homeostasis is an internal condition that is the same, okay? What do I mean by that? Or maybe I'll give some examples. So like you and I we're both alive, and our internal body temperature is around 98.6 degrees. It could vary. It could be a little colder than that, a little hotter than that, depending who you are, but it's not going to change massively. If your body temperature dropped by 10 degrees, you will probably die. If your body temperature goes up by 10 degrees, you will probably die. And so that's what I mean by homeostasis, is your body temperature is not really fluctuating very much beyond that 98 degree range. Okay, it's not changing by very much. The other things like the pH of your blood are going to stay pretty much the same throughout your lifetime. It's never really going to become more basic or more acidic. Things like your body's overall salt concentration, it's never really going to change a ton throughout your lifetime. And so living things need to be able to maintain similar internal conditions. Do viruses do that? Or specifically, does the coronavirus do that? And the answer to that question is not really. They aren't really capable. They don't have the machinery that your body and my body, or even a single-celled organism's body has to be able to maintain internal conditions. There's some argument about this one in particular, but really they're not super able to maintain homeostasis. They're just kind of subject to whatever environment they happen to be in. So here are our characteristics of life. And let me ask you guys this question. Is coronavirus alive? There used to be some debate about whether or not viruses are alive, sort of amongst biologists. It's been pretty much settled. There are still some folks who argue that viruses are alive, but generally it's accepted that viruses are not alive. They're not dead, because death implies that you were once alive and then died. But viruses, at least according to a vast majority of biologists, are not alive. But what you should notice, and a question that I'd probably give you on an exam, is, certainly viruses have many of the characteristics of life, right? They're highly organized, they adapt, and they evolve. They don't have all of the characteristics of life, but certainly a lot of things can have the characteristics of life without actually being alive. Okay, and so that's something that you need to keep in your head, is that these categories aren't like black and white. So if something responds to a stimulus, if something uses energy, that doesn't mean that it's alive. Okay, you need to have all of these characteristics to truly be alive. Okay, so that's the end of this lecture. And the next lecture, we're going to move on to talking about the scientific method and just keep on crunching through chapter 1.